Good to be here. So as she told you, I am an astrophysicist. So it's not often that you get an astrophysicist at your beck and call. So what I'm gonna do is I'm gonna not immediately open the floor up for whatever questions you may have about the universe or anything else, because as you know, astrophysicists know everything. So the first thing, though, I want to talk about is you and your own life's journey. You know, leadership is a part of what you're doing, right? And leadership is a part of mentoring. And so one of the things that I love to do is mentor young people. And a big part of mentoring, I say that we all need three things in order to make it: hope, hustle, and help. All right? So what's hope? Hope is the belief that you can achieve whatever it is you set your mind to. And the good news for you is that you're in the best country in the world to do that, right? My life as an astrophysicist comes with certain perks. And one of them is that I get to travel the world a lot. So at this point, I've been to 44 countries around the world. Guess how many of those trips I had to pay for? Zero, right? They're all business trips because science has been globalized since, before globalization was a word. And really, what this has allowed me to do is have a good perspective on the country that I live in, a good perspective on America. And when you hear that America is the land of opportunity, it really, truly is. As a matter of fact, I'm in my mid-50s now, so I've known a lot of people. And every person that I know who wanted to become something outside of sports and entertainment that actually tried to do it, they achieved it. So the wonderful thing about our nation is that the limit that you have is primarily the limits that you place on yourself. But that doesn't mean that it's easy, right? So let me just tell you a little bit about my own personal background. So no one in my family prior to me even graduated high school. My father dropped out of school when he was 9 years old. My mother dropped out of school when she was 16 years old and pregnant with my older sister. As it turns out, my mother's mother dropped out of school when she was 16, and so did my older sister drop out of school when she was 16. And so here I am, born into a family where no one achieves anything through education, right? We were basically blue-collar workers. So I actually started working, doing hard labor in the woods like you see around you at the age of 12, right? I was hauling pulpwood at the age of 12, farming from the age of 9. And none of this, my parents taught me what they knew. And what they knew is how to live and survive in the country. None of that stuff gets you into Harvard, right? That's about academics. And luckily for me, after I left home, the first place I went was to the U.S. military. I went to the United States Navy. And the big barrier for those of us who want to do science is typically mathematics. As a matter of fact, for those of you who choose to go to college, one of the things you're going to see is that when people go to college and they have to choose their major course of study, they ask themselves three questions. The first question is, what do I like? What do I enjoy? The second question they typically ask is, what can I make money doing? And the third question they ask, what has the least amount of math? So math is the key. And when I went to the Navy, I learned algebra for the first time in my life. So I went to high school and middle school in the state of Mississippi. But in the Navy, I learned mathematics. I go to college, and then I find that there's this whole new world out there that I did not yet know exists. But I was unprepared for it. So after hope, the next step is hustle, all right? So what does hustle mean? Putting in the hard work. There are very few things that you cannot accomplish if you actually put in the hard work and don't stop. As a matter of fact, when I stepped into the world of being an astrophysicist, typically, here's how things go. You look at some problem in the universe and you say, hey, let's solve that big problem in the universe. But then you think, well, to solve that problem, we need to make some measurements on the universe. But the tools to make those measurements don't exist. So let's invent those tools. Let's invent those instruments. But when you invent those instruments, you have to have a way of calibrating them, of making sure that they're doing the job that you want them to do. So now you have to invent some new technology in order to do those tests, in order to even make the new technology, in order to even make the measurement. So what I'm saying is, when you step into a lab, whoever the head of the lab is, they're going to look at you and they're going to say, all right, let's do the impossible. You ready? But guess what? Then you do it. So for example, Have you guys heard of the James Webb Space Telescope? That thing is insane. It's also pretty impossible. Like, the fact that it works the way it's supposed to work, it is easily the most complex astronomical observatory ever created, and yet it works to the T. And that's because of hard work and rigor, that hustle that I was talking about. Now, the final thing is help. Hope, hustle, and help. What do I mean by help? Well, I think that especially in the STEM, in the sciences, engineering, mathematics, what we do is not intuitive. Nobody's born thinking like a scientist, all right? It is hard work to get there, but it's also weird. It's difficult. So the best way to get there is to become the apprentice of someone who's already doing it. That's the help. But one thing I've learned in life is that when you help others, you get help more. What do I mean by that? When you go to school and you learn a subject, you're like, oh, I got a degree in this subject. Now I got a doctorate in this subject. And you think you know it. But you go on to find out that you really don't learn it well until you actually teach it. And what I find is the phenomenon is very much like music. Sometimes there's a song that you've known for years, and there are lyrics that you never quite understood in that song. And then one day, years later, you hear the song again, and now the lyrics are plain as day. And you're like, oh, I didn't know that's what they were saying, right? So learning science, learning the universe works exactly the same way. You start doing this stuff, you do it in high school, you do it in college, you may do it in graduate school, and you think you've learned something at every step, but you learn later that there's always those lyrics you never quite understood, and eventually you get it, right? But help are your human resources. Nobody does anything alone. When you see your favorite musician write an album, and they're out there singing it in front of everybody, say you're Harry Styles, in the background, there's a team of people that actually made that album. If you read a book and it has an author's name on the book, in reality, there's a team of people behind that book that made that book. So one of the big misunderstandings that we have when we're young is that people do things by themselves. No one who does anything well does it by themselves. So I get tired of hearing myself talk. So what I wanted to leave with you is we live in this impossible nation called America, right? It's diverse, which in most nations is a recipe for nonstop conflict, but yet we're peaceful. We're also pretty prosperous here in this nation, right? And so you hear a lot of people talking about like the problems we have in our nation, but let me tell you, there are a few places in the world, if any, that have it better than we have it here in the United States. The ease of life that we have is not to be taken for granted. It is something really to be protected. So what I want to do now is open the floor for your questions about the universe.
My name is Paxton Bowers. I'm from Atlanta, Georgia.
Ah.
And my question was, what do you do as an astrophysicist?
So it really changes from day to day, year to year, based on what project I'm on. So most of the time, I'm working with building something, right? I like to build satellites, and so astronomical satellites. So the first technology that I worked on, you probably are aware of. If you ever seen the pictures of the sun with all the plasma loops on it, so I was on the team that did that first. And then from there, I went to Silicon Valley. And so my patents that you talked about are in the computer chips you use every day. And then from there, I went to work on a telescope that is not yet in existence. It's known as the Nancy Grace Roman telescope. I worked on detectors there and a lot of other observatories. So sometimes I'm in the lab making measurements. Sometimes I go to observatories around the world to do observing. I take students with me. And sometimes I'm just on my laptop in a coffee shop doing data analysis.
Hello, I'm Ray. I'm from Oregon.
Yes.
And I was wondering, the Big Bang, what
Yes.
direction, did the Big Bang happen in?
Exactly.
that
That's a
work?
great question. You know, when you hear the description of the Big Bang, it sounds like an explosion that started somewhere and spread out. But that's not what it is. It's a misnomer. The word Big Bang was created by a scientist to make fun of the idea. No one liked that idea, right? But as a physicist, we have to listen to the data. You know, one of the things that happens sometimes is people will say to me, Dr. O, you said that science says, and I correct them. They're like, oh, science doesn't say, science listens. Universe, tell me what you are, and then you have to go with what it says. So what the idea of the Big Bang is that space everywhere expanded simultaneously, right? So imagine I have a rubber band, and imagine my rubber band is 1 foot long, and I stretch it so that in a second it's 2 feet long. Wherever you are on the rubber band, you have a different observation of what happened. If you're at the center of the rubber band, you see the two ends move away from you. If you're on this end, you see that end move away from you. If you're on this end, you see that end move away from you, right? So no matter where you are on the rubber band, you see every other point of the rubber band moving away from you. But here's the thing about the Big Bang that lets us know it's stretching, right? If this end of the rubber band moves 1 foot in a second, the center of the rubber band only moves half a foot a second. Because now that the rubber band is 2 feet long, the center went from being half a foot away from this end to 1 foot away from that end, right? So it moved half as fast. And the little piece right here where I'm holding the rubber band didn't hardly move at all, right? And so what you see in the universe is that galaxies that are twice as far away move twice as fast away from us. 3 times as far away, 3 times as fast. They move 3 times as fast. So the rate at which you move away, so what lets you know it's stretching versus something else is that everything is moving away from you, and the rate at which things move away is proportional to their distance. Double the distance, you double the rate it's moving. Great question, thank you.
What are some of the things you got patented in? Like some of the inventions?
Yeah, so
Like
one of
last
them, so when I was, one of the things that I like to do is study light. And so a question I have for you is, where does light come from? That's what everyone says. When I say, that's the second answer. All right, now let me tell you the real answer. Those are the 2 answers everyone on the planet gives. I've been asking this question for 20 years. The easiest, simplest answer is matter makes it. That's where light comes from. You're made of matter. Are you emitting light right now? Yes, you are. In what wavelength? Infrared, exactly, right? Every opaque body around you is emitting infrared light. So the first thing I did is I got really, the thing that allows us to do astrophysics is that when matter makes light, the signature of what the matter is and what the matter is doing is encoded in the light. So when I look at a star, it's just a dot. But yet I can tell you, here's what it's made of, here's how far away it is, here's how it's moving. How do I get all that information from that dot of light, from reading the light? So a part of my patents are about how you use light to make computer chips. Another part of my patents created the last generation of what are known as planar transistors. And then my final patents are on ion propulsion.
I'm Abby Baldridge. I'm also from Atlanta.
Yes.
My question is, do you think it's possible to get high up in the world without facing challenges and failing?
Woo, what a question. I mean, it hasn't been possible for me. I've done a lot of failing and challenging, let me tell you. You know, I used to say that I don't know if I'm a winner or a loser because I've lost way more than I won. But the thing is that people only see the wins. So, you know, external people think you're a winner. But internally, I'm like, that's not how I see myself. I'm a trial and error. You know, the physicist in me would say that every possibility is going to occur. All right. So one possibility is making it without having those challenges. All right. So that probably does occur. But what is more likely? And I think your starting place also matters, right? What you go through, life. There's a joke someone told me many years ago, and I don't know if I'm saying it correctly, but it was something like, how do you make God laugh? Tell him your plans. So I was going to be a Navy nuclear submarine captain. That was my career path. I went to the Navy. I joined the Navy at the age of 17, went away to boot camp, got diagnosed with atopic dermatitis, which was horrible. And I'm like, yes, finally I'm diagnosed. And they're like, yeah, but you're not allowed in the Navy with this. See ya. So there was my plans gone, right? Then I started college. I'm like, yeah, I'm going to be chemistry pre-med. And then I took this course called organic chemistry, into that. So, life keeps doing that to me. And so the thing about us is that we have a resilience built into us. I think a lot of the world around us today is trying to get people to treat each other well, treat each other nicely, be nice to each other, right? But that doesn't always happen. And so you do have to build resilience. And I think that a lot of us, when we're climbing the ladder, you start off with something to prove, and that's what keeps you going when the times get tough. And so when times get tough, what pushes you forward? That's what you have to identify. But by all means, please push forward.
My name is Sebastian from Puerto Rico.
Nice to
and
meet
my
you.
question is what is the universe expanding into?
All right, first off, my two best friends in graduate school were Puerto Rican dudes. Inictali Figueroa Feliciano, who's now a professor at Northwestern University, and David Santiago, who's now the lead of Berkeley's quantum computing lab, right? Yeah, and I got a lot of great phrases from my Puerto Rican friends. I'm not gonna bore you guys with them, but they're golden. So when we model the universe, and that means we write down mathematical equations to describe it, our 3D volume, we model it as what we call a 4D hypersurface. So this surface does not require, so in our modern mind, right, we think of, we're 3D entities. And so if something is going to expand, like say the surface of a balloon, it expands in that third dimension. But the universe mathematically, I have to show it to you mathematically, you do not require a higher dimension to expand into to expand the surface, right? So the question of what is the universe expanding into is sort of like what's north of the North Pole. There are certain geometrical situations that yield certain questions nonsensical, even though it seems valid, and so it's always a devil in the details type thing. This stuff is so subtle. There's a reason why all physicists have completely white hair. I do too, but I color it. So.
Hello, I'm Lorenzo from Puerto Rico. Do you think aliens exist?
I do. I think that life exists. So there's two questions, right? If you look at life on Earth, for the vast majority of Earth's history, life has been very simple life forms, right? Microscopic life forms. So it's only the last ninth, or let's say 10% of Earth's history, the Ediacaran, have we had multicellular life forms like ourselves. And what allows multicellular life forms? Oxygen respiration. Where does the oxygen come from? Photosynthesis. So if you look at the history of Earth, it took 2 billion years. So here's what makes Earth different from other planets. When we look around and we find other planets, we found almost 6,000 around other stars. We have about 38 gravitationally rounded bodies in our own solar system, and atmospheres typically come in one of two types. Super thick, like Venus, Jupiter, Titan, Saturn, Uranus, Neptune, or completely absent, like Mercury, the Moon, Ceres, Europa, Ganymede. Earth has a very thin, transparent atmosphere, so light can get to our surface. That's not common for planets with atmospheres, all right? And so, if you think about it, Earth life, as early as we can look back into the fossil record, it exists. The evidence goes back to, say, 4.1 billion years, all right? So life starts early, and it's bathed in sunlight for 2 billion years, and that's how long it takes for oxygen-producing photosynthesis to become widespread under ideal conditions. It then takes another 2 billion years for that life to learn to use oxygen for oxygen respiration and build multicellular animals like ourselves. So creating macroscopic multicellular animals is really, really difficult, all right? Creating bacterial life is really easy. So bacterial life is probably everywhere. I calculated that there should be 1 out of every 150,000 stars or so, 1 out of every 100,000 stars should have multicellular life on it. But here's the thing. If you get multicellular life, what's the probability that you get intelligence? I say 100%, because we're all taking in data and we have this processor we call the brain, and that just naturally leads to intelligence. What's unusual is an advanced technological civilization. Out of over 5 billion species to exist on Earth, there's only been one advanced technological civilization. So when I say that aliens exist, I'm talking about primarily in the form of bacteria and simple life. Just like if you had come to Earth for 90% of its history, that's what you would have found. You would not have found us, all right? Are there multicellular life forms out there? Has to be. Is there another intelligent technological species? Well, in the entire universe, definitely. But in our galaxy, I expect them to be very, very few. But also remember, most planets do not orbit stars. So, that's a whole new set of opportunity there.
My name is Cheyenne from Vancouver, Washington, and my question is, how did the known structures of the universe evolve?
We don't know, but so basically we thought we knew, but the James Webb Space Telescope has shown us that actually we don't know. Because many of the processes, just like if you look at West Virginia, it has an interesting topology. There's lots of different hills and valleys, right? So if you look at water in a state like Virginia, right, it flows from uphill to downhill and it collects in these basins that we call lakes and rivers. It flows from rivers into lakes and eventually to the ocean. The universe does the same thing. But instead of water flowing from higher altitudes to lower altitudes, mostly there is hydrogen gas flowing from areas of the universe with very little space-time curvature to areas with a lot of space-time curvature. All right? So what happened in the early universe is the stuff that we call dark matter collected gravitationally first. And that created the areas of strong gravity, what we call strong space-time curvature. So then the matter later flowed into those gravitational depressions created by the dark matter, and that's where the galaxies are. But before that, there are these processes that happened in the very early universe. For the first 380,000 years, the universe was all plasma. We call it the primordial fireball. And in that process, where the dark matter was clumped together, matter would fall in, but the matter is what we call ionized. Electrons were ripped off the atoms. And just like metals are shiny because they have free electrons in them, right? Free charged particles like electrons and protons interact really strongly with light. So when you look at a metal, it appears shiny because those surface electrons are absorbing light of all wavelengths and re-emitting it, and that's what you see as the shine, right? Well, in the early universe, when matter starts falling into these dark matter concentrations, the light is bouncing between these particles and applying a pressure. And the smaller and tighter the matter gets, the greater that light pressure becomes. So when it gets to a certain density, the light pushes the matter back out. And then once it gets dilute, it now falls back in because of light pressure. And so it does that over and over. And that's called an acoustic oscillation, all right? And those locations, if you imagine this matter falling in and out, those are where galaxy clusters form, but also it's like dropping a rock in a pond. You get a wave that goes out. And this wave goes out through the plasma, and where those wave crests are is where galaxies form. So our galaxy is formed on one of those crests, for example, and that's how the large-scale structure comes about as far as we know.
Hi, my name's Molly. I'm from Atlanta, Georgia, and I was wondering what religion, if any, you belong to, and how do you separate your faith in religion from scientific evidence?
All right, so I was raised Catholic in my early childhood, and then we all moved to Mississippi, and we all joined a Protestant church. All right, now the so-called disagreement between faith and science, I think it's a made-up thing. It doesn't appear to be real to me. I think what happens is, with science, what we're doing is we're making observations and we report what we observe, all right? And that's a very different thing than our faith traditions, right? It's not, let me go out in the world and make detailed measurements, right? You don't open the Bible or the Quran or anything and see a description of atoms and electromagnetic waves and Maxwell's equations. It's a completely different thing. So for me, it's not really a battle at all.
Do you think there is any side effects that we don't know of from global warming?
Oh, man. It's very complex. Weather in itself is a non-linear phenomenon, as we say, and it's chaotic. So that means that, when you use science to predict things, that's the real power of it, is to predict. Then, situations like that, where it's chaotic and non-linear, it makes it very difficult to make predictions going forward into the future. And this whole process of what's happening globally with our climate is surprising us over and over and over, right? We keep finding that there are unanticipated changes occurring, and the rate that change is occurring is unanticipated. But let me give you a slightly different perspective about global warming. And this is something for your generation. Our atmosphere is so thin and so nearly non-existent, we can actually engineer it to be what we want it to be. We haven't done that. What we've done is we've gone about our commerce and our lives, and then we say, oops, acid rain. We didn't realize that having factories that put out this particular stuff causes our rains to become acidic and destroy things. Let's fix that. Then it's like, oh, these chemicals we're using in our refrigerators and other industrial complexes, they're destroying the ozone layer. Let's fix that, right? Now we're like, oh, the carbon that we've put in the atmosphere is a greenhouse gas and it's causing the global atmosphere to warm. Oh, let's fix that. Well, instead of being reactive, let's be ahead of the game. Let's be ahead of the curve. Let's get an international treaty where we decide to engineer our atmosphere for the good of all humanity, right? Hard to do, you need the political will to do that, but I think that as a planetary species, that's the way we should be thinking. But, good luck getting the humans to do it.
Hi there, my name is Parker Mercero, and I come from Oregon, and I was wondering, do you think at some point in the future that we can achieve time travel?
Yeah, so, it's really weird. So there is, relativity that allows you to move at it. So there is no such thing as the age of the universe. Remember how I told you how the universe, material flows from low curvature to high space-time curvature? Well, where space-time curvature is greater, time passes more slowly than when there's less space-time curvature. So here on the surface of Earth, time passes more slowly than when you're up in an airplane. We've actually measured it. All right, it's a real phenomenon. So when we think of time travel, we think of being able to go into the future and into the past. So there's only one way we know of for going into the past, and that involves using what we call a wormhole. And, if you attempt, a wormhole is a black hole, and, you go into a black hole, you're not likely to survive that.
Hi, I'm Jesse, and I'm also from Atlanta. And my question is, what have you discovered while being an astrophysicist that you could not believe was actually true and possible?
Well, I first started off studying the sun, and I was working on two problems. One is the source of the high-speed solar wind, and there were these structures that appeared to be, it's definitely those, right? We knew where this high-speed solar wind was coming from, and you could see these things jetting out of it. And we went and measured it for the first time back in 1997. We published this, and it turns out they were not the source of the high-speed solar wind. So that was like, oh, I didn't expect that. But the other thing I don't expect is anytime it works. You get this data, and your data is always on the edge of what's possible at the time. And then you're like, okay, I can't actually see it. So let me go on my computer and build a model and make my model fit the data, and then I'll tell you, here's what it is. And you publish that, and then later somebody makes something that can actually see it, and then you see that what you predicted is actually what it is. Mind-blowing.
I'm Javier Portela, and I'm from Puerto Rico.
Yes.
I just want to ask, what has been your greatest achievement, and how hard was it to get there?
Man, my greatest achievement is being alive. So my the youth version of my memoir is coming out on August 15th. I would recommend you reading it. But, I grew up in really tough circumstances. And, there was a lot of gang activity in my family and crime activity in my family, and I was involved in it. And I personally found myself at gunpoint on no fewer than 10 occasions in my, teen and early 20 years. And man, how do I make it through? A big amount of luck. And also, we're so adaptable, right? And so there are certain situations where I tell people, how do you think you'd react in this situation? Because when you go through the situation, you're surprised. I get surprised. So for example, one time I took my students to this small island in the South Pacific in 2010 to make observations of a total solar eclipse. We were almost killed 3 times on that island. One time was an airplane coming right at us. This island had fewer than 400 inhabitants, all native Maori. The airport was a dirt strip, and we were on the edge of the runway practicing for the eclipse the next morning, right? Going through our experiment. And, planes are taking off, and they're way in the air before they get to the end of the runway. This one plane comes over the hill and is still on the ground. And then it gets a little bit of air, and a wind gust hits it sideways. It's coming straight at us. So the question is, what do you think the first thought is that goes through your mind when you see an airplane coming at you from 30, 40 yards away at 100 miles per hour? Run. You think run. That's not the first thought. The first thought is, there is not an airplane coming at me at 100 miles per hour. It's complete denial. Right? That's the thing, right? And so the same thing happened when I found myself this one night in 1990, I was kidnapped. and I was held with like 5 guns on me, and the crazy thing about it is, do you think I never had a moment of fear in the moment. I was the most polite and easy to get along with guy. But, the next day, it was an emotional breakdown. But in that moment, and what I say that to say is how adaptable we are. We run into tough times, and you can rise to meet the moment. My experiences are pretty drastic. The chances of you experiencing what I experienced is unlikely, right? I was putting myself in situations. So, if you find yourself in a tough spot, finding a way beyond that tough spot to make it another day. I'll give an example. I get to Stanford University for graduate school for my PhD. My second quarter, I take my midterm exams, and I get the lowest score on every exam in every class. All right? So I decide I'm not smart enough. I'm going to drop out. I go to my advisor's office. He's not there, so I sit on the floor in front of his office door and waiting for him. And so this other professor comes by who would later win a Nobel Prize in physics, a guy named Doug Osheroff. And Doug is like, what are you doing? And I'm like, I'm dropping out. And he's like, why? I'm like, I'm not smart enough. He's like, come into my office and talk to me. And I told him what happened. And he said, okay, tell me what courses you're taking right now. And I told him. He's like, okay, what are you doing in quantum mechanics? I told him, he's like, okay, go to my board here and solve this problem. I did it. He's like, that's nice. What else are you taking? I told him about this math class I'm taking. He's like, okay, go to the board, solve this problem. And he gave me 3 problems, and each one I solved them. And he said, you don't seem so dumb to me. How about you stay a little while and let's see how it works out? Here I am today with that PhD, right? So without Doug, would I have stayed another day, right? That help that showed up. So when I say resilience, it doesn't always come from internal, right? Sometimes the people around you providing you support and encouragement. Sometimes it's people challenging you. For me, I'm the type of guy, when someone tells me I can't do it, my first thought is, I'll show you, right? Other people, you tell them they can't do it, they're like, you're right, I'm out, right? So, building that resilience and that grit is key to achieving whatever it is you set for yourself. But if you do, you're unstoppable. And if you work in concert with others, you're really unstoppable.